This is example 2 from chapter 15 of your student packet. It says, in the 1980s, it was generally believed that autism affected about 6% of the nation's children. Some people believe that the increase in the number of chemicals in the environment has led to an increase in the incidence of autism. A recent study examined 384 children and found that 46 of them showed signs of some form of autism. Is there strong evidence that the level of autism has increased? Use a significance level of 0.05. And then it says, write the name of the test, state the hypotheses, find the p-value and test statistic, and state your conclusion. So we're going to start by checking the conditions. So we want to make sure that all the conditions and assumptions are met for this test. So first, we typically want to make sure that the sample is random, and it doesn't say that in this problem. We really don't know if the sample is random, so it's something that researchers would probably follow through on and say, was this actually a random sample? We're going to keep moving forward, though. Number 2, the second thing is we want to make sure that the sample size is less than 10% of the population size. So this is the 10% condition. And in this case, we've got a sample size of 384, which is less than, that's got to be less than 10% of the population of all children. Right? There are millions of children in this country. All children's, I don't know why I wrote that. Okay, number 3. We want to make sure that we meet the success failure condition. Actually, usually right here is where I talk about independence. And I usually say that if the sample is random and we have a sample size that's less than 10% of the population size, then we are fairly sure that our sample is independent. We don't know if we have a random sample, so we're going to assume independence here. Number 4 is our success failure condition. So we saw this same condition when we were doing confidence intervals. So we need at least 10 successes and at least 10 failures. So our successes, remember, equal n times p. So in this case, our sample size is 384, and the population proportion is 6%. So if we multiply those, we should get about 23, which is greater than 10. And that also means that our failures, which would be 384 minus this 23, or NQ, 384 times 0.94, is also going to be greater than 10. So this is 361, which is greater than 10. So we've met all the conditions. Let's state the hypotheses. So the null hypothesis, so it's said that it was generally believed that autism affected 6% of the nation's children. So remember that the null hypothesis is that the proportion has not changed. So the proportion would be 6%. And the alternative hypothesis, they want to know, has this proportion increased with the level of chemicals increasing in our environment? So they want to know if this proportion is greater than 0.06. So then we're going to run a 1-prop z-test. And to do this, we're going to use our calculator. I know that there's lots of videos showing you how to do all of this by hand. Remember, I don't want you to run any confidence intervals or any tests by hand. So we're going to go to your calculator. You're going to go to Stat, Tests, and you're going to choose number 5, which is the one prop z-test. And for this, we're going to put in our p sub 0. So when it asks for p sub 0, it's asking for the p-value of your null hypothesis, which in this case is 0.06. Then we have the x and n. This was the same x and n for your confidence intervals. So the x was that we had 46 out of the n, which is 384 children. Then it says prop. This wants to know for the alternative hypothesis, what is the symbol that you're using. Notice that our alternative hypothesis is a greater than, so we would use a greater than. So you're going to arrow over to the greater than p sub naught and hit enter, and then you're going to go down to calculate. And when you calculate this, you're going to record the test statistic and the p-value. The test statistic for a one prop z-test is z. So this is the z-score. The z-score is 4.934 for this test. That's a very high z-score. And it gives us a p-value, therefore, that's really small. It says 4.0417 e to the negative 7. Remember that the p-value is a probability, so a probability cannot be greater than 1. This negative 7, e negative 7, means that there's 6 zeros in front of this 4. So our p-value is extremely small. 2, 3, 4, 5, 6, 40417. So from here, we're going to state our conclusion. And in your homework, I show you how to write out a conclusion. So the first part of your conclusion is always to say whether or not your p-value is above or below your significance level. So we are using a significance level of 0.05. So we would say, since the p-value is below our alpha, we use alpha to signify our significance level, below alpha equal to 0.05, we reject the null hypothesis. I'll explain this here in a second. And conclude that there is enough evidence to suggest that the level of autism has increased. So first I want to talk about what is a p-value. A p-value is the probability that we would observe this sample given that the null hypothesis is true. So given that 6% of the nation's children have autism, what's the probability that we observe 46 out of 384 of them? Well, the probability is extremely small. And since the probability is extremely small and our sample was very good, that would mean that we have evidence against supporting that null hypothesis. So we are rejecting the null. Notice we're not accepting accepting the alternative. That's not what we're doing. We are showing evidence that the null is not true. And then we are saying that there is evidence to suggest that the level of autism has increased. I'm not saying what the level of autism is, but I'm saying that it's higher than 6%. And I'm just suggesting that based on this one sample, that could be what's happening.